Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
We now want to just take a look at the calibration of these autoclaves. So my name is Janet Douglas, and I'm a biomedical engineer for the Oxygen Alliance. I'm glad to be your host today. So I'd like to know where you're joining us from, as I'm joining this call from Lilongwe, Malawi, which is the capital city of Malawi. So please type in the chat where you're joining us from. And also, if you want to be on our emailing list for the Oxygen Alliance events, communications, in terms of the webinars, please type your email in the chat as well. So this session will be a little bit different from how we would do all our sessions. It's going to be an interactive session, and there will be areas whereby we'll be asked to give in our comments or the experiences that we have had in terms of the challenges or the problems in the calibration of these autoclaves. So you're free to speak, and you'll be given a chance to unmute yourself and say something after you raise your hand. And also you have the right to just type in your question or your comment in the chat when the time comes. So today we have a guest from Uganda who is Engineer Rose. She also introduced herself and one taking us through the entire presentation. Thank you very much. Over to you, Engineer Rose.
Thank you, Janet. Like Janet mentioned, my name is Rose Achom. I'm a biomedical engineer by profession. I've been in this profession as a biomedical engineer since 2012. And I have.
If I don't know if it's possible, maybe just please turn on your camera for people to see you. I don't know where you are, if it's okay for you to do that.
Unfortunately, I was in another call, so I just stepped out briefly just to come and make this. So I'm going to just say, okay, turn on briefly, but I'll turn it off later because the place is not very convenient. Okay, so I'm in the car for now. Sorry about that. So thank you. My name is Rosa Chom. I'm a biomedical engineer by profession in Uganda, and currently working at the National Health Laboratory and Diagnostic Services. Like I was saying, I started this profession of biomedical engineering in 2012 from Chambogo University as a as a biomedical technician, then joined the Uganda Heart Institute. Thank you.
Yeah, I think at this point you can proceed, but I would like to ask you to turn off your camera now, because I think we're having network issues from your end. So maybe if you try to turn off the camera, it will be more clear. Thank you. You can go ahead with the presentation.
Okay. Thank you, Janet. As per our discussion today, Janet explained that we've been going through maintenance of this equipment, operation of this equipment, and specifically the autoclaves. So today we want to look at how do we perform calibration of autoclaves. This is an introductory part of calibration. Calibration is very wide, and for each equipment, when you're performing calibration, for each equipment, you require a particular method. So this is just to open our eyes and see what we actually need when we are calibrating autoclaves. So after that, we can as well move further on how to make it realistic in terms of our respective places that we are working with. Okay. So briefly about where I work, this is the NHLDS NEC Lab. So the NHLDS is a department at the Ministry of Health in Uganda, and it is responsible for coordination of laboratory services across the country. So NHLDS being a department for coordination, the arm of coordination, it established different sections that help. So we have the testing section where we have the CPHL labs, Central Public Health Laboratories. We have biorepository, we have logistics and supply chain, and then we also have equipment and infrastructure. So under equipment, we have the National Equipment Calibration Center, hence the word NEC Lab. So this Uganda Calibration Center was established with 4 core sections. We have the calibration laboratory, where we handle calibration of equipment. And calibration, we are accredited against 17025, which is the competency requirements for calibration and testing labs. And we are accredited for 7 scopes, which include volume. And like I mentioned, it is laboratory equipment. So when we talk of volume, we talk of equipment that are used in the laboratory in respect to volume. So like the pipettes that you see, we have glassware, burettes, yeah, that line. Then we have mass, which is another scope. So in mass, we calibrate the analytical balances. So like the analytical balances are a very small scope. So we don't exceed 2 kilograms. And then we have, we also accredited for time. And time here, we do the digital timers, we do the stop clocks, we do the wall clocks, we do the stopwatches. Yeah, anything that is time. Then we are also accredited for speed. And in speed, we calibrate the centrifuges, the rotators, shakers, basically rotational speed. Then we are also accredited for pH, and we calibrate pH meters. We are also accredited for pressure, which is also a sub parameter that we are going to discuss today. So under pressure, we calibrate the pressure gauges, and we also calibrate the autoclave pressure. We also do testing of the manometer, which is the pressure difference across different points. Then we are also accredited for temperature, and also one of the parameters that we are going to discuss today. So in temperature, we have so many subscopes. We have calibration of thermometers, we have calibration of chambers, that includes all this, anything that is conditioned, like the autoclaves, we have the fridges, we have the ovens, we have the water bath, incubators, to mention but a few. And for the thermometers, we calibrate the infrared, the temperature guns that we've been using during COVID. We have the liquid in glass or the mercury thermometers. We have the digital thermometers. Then it also includes the subscope of humidity, which we also do. So that is the first section of calibration. Then we have a second section of biosafety cabinet certification. Like I said, I am NSF accredited. NSF is the international body that certifies biosafety cabinet certification engineers across the world. It is a US based. I believe some of us have interacted with people who are performing maintenance and certification of biosafety cabinets. So they have to be internationally accredited. Yeah, and here we do basically the certification, we do decontamination, we do installation and repair of biosafety cabinets. Then we have another section, which is the equipment maintenance workshop. This one where we all biomedical engineers, we we should be able to actually maintain equipment. So in Uganda, we have a section of regional workshops. We have about 16 regional workshops which are established across the country. So we work together with these regional workshops to ensure that equipment are serviced. And finally, we have the training and mentorship section where these webinars lie. So under training and mentorship, we train in-service engineers. We have an accredited curriculum that we follow when we are training in-service engineers in different sets of equipment. We have about 11 modules that we train on. So this is a big component that we strengthen a lot, and working with Oxygen Alliance, I think we can move more and more to see that we can give services to the people. So the training, this is actually across the continent. Like currently we are running a project together with the East Central and Southern Africa, which we are training many engineers across the country who are serving the lab and yeah, we are building capacity first in biosafety cabinet certification. We're building capacity in calibration and also maintenance of laboratory equipment. So basically that is about the calibration center where I do work. So back to the reason as to why we are here. We are talking about calibration of autoclaves, but we needed to understand what is calibration. Why is it important for us to actually perform calibrations? Generally, most of the time, this is a very, very key aspect. Why? Because it ensures reliability and quality of services that we offer to the people. The patients that we are working on, or the patients that are being used to, to diagnose a disease. It is very unfortunate that a patient will go to a hospital and they tell them your blood pressure is very high. But in actual sense, it is the equipment which is actually having a problem because it was not calibrated. So there is no quality of service being delivered to this patient, and you're causing harm to the patient. So calibration is a very, very key aspect, okay, when we are performing our maintenance, or when we are planning for the equipment life cycle. So most of the time, we engineers, when we are doing the service and maintain equipment, that is it. Yeah, we forget to actually perform either verification or a calibration, because sometimes calibration may not be easy to do. But at least let's do a verification, okay? And it will bring to a discussion when we shall have it towards the end, that what makes the difference between verification and calibration. Now, when we are performing calibrations, like I said, like our calibration lab is 17025 2017 accredited. So 17025 provides competency requirements for calibration and testing laboratories. So most of the time you look at this 17025 so that it's a guiding document that will give you general requirements when you're performing calibrations. It does not specify that when you're calibrating an autoclave, this is what you should do. No, but it will tell you that when you're going to perform calibrations, you have to have maybe a valid method. So you go and look for a method for calibrating autoclaves. You have to ensure that your equipment are calibrated. So you go and look at how am I able to calibrate my equipment that I'm going to use to calibrate other people's equipment. It will tell you how you're going to report your calibration results. So when you're coming up with the report of your calibration, you put all the aspects that are given by the 17025. Okay. All right. So for autoclaves, first and foremost, why are we even bothering to understand why we need to calibrate autoclaves? So why do we need to calibrate autoclaves? First, the thing that I mentioned, patient safety. Okay. We are looking at an item that the doctors assuming that the instruments that they are using on this patient are sterile. Okay, so if they have that much trust for this autoclave that is actually giving us the sterility, then we as engineers, we should be able to actually 100% say that yes, this autoclave is able to sterilize equipments. So the items that are being used must be sterile. You don't want patients to have infections after after maybe a surgery has taken place. Okay. 2, sterilization efficacy. How do we know that the autoclave has attained? We talk of 121. What is the I think the most for sterilizing instruments is I think 121. So 121 degrees Celsius. How do we know that the equipment has actually attained 121 degrees Celsius? Okay. If it is supposed to be at a certain pressure, how do we know that this pressure has been attained and the sterilization process has actually started? All right. The third one is compliance with regulations. We all have regulations in the respective in our respective countries. So this calibration also helps us to come up to follow and comply with these regulations. Most of the time, these regulations actually work in the negative side, that when a patient has a problem, that's when they will come and say, were this equipment calibrated? Maybe the patient has even put the hospital in court. Yeah. So now they start looking at the equipment, and unfortunately, they find that the equipment was not calibrated. That is the first thing that they will actually consider. However much you serviced and maintained, you have a PPM schedule that you follow, but once the equipment was not calibrated, it becomes not compliance to the regulations. Then it also leads to reduction of equipment damage. How or why? When you're doing the calibration, sometimes you may find that maybe this autoclave must be operating at, say, 2 bars. Okay. But then during calibration, you realize that it actually exceeds the 2 bars and it goes to even 4 bars. So what will happen eventually? An explosion may occur. Okay. Temperature, maybe it is supposed to be at 134, but in actual sense, it is going up to 150. So you start seeing the boards, the heat sink is getting burnt out every time, you know, all that. So it reduces on equipment damage. So you reduce on definitely the downtime. So when you are doing the calibration of autoclaves, what are the key parameters that we should consider when we are calibrating an autoclave? First is the temperature. Okay, remember, for sterilization to take place, we need to attain a certain temperature and pressure, and then we perform this stage at a given set time. So the key aspects that we look at is temperature, we look at pressure, and we look at time. In temperature, we have different you can have about 2 equipment that you use to actually perform the calibration of temperature parameter. One, we have the thermocouples. This could be of different types. You have the common types are the type K and the type J that are common, and we've seen also their stability. Type J and type K are a bit stable, but of course type K is the in my working, type K is the most stable. So looking at that, but also you look at the size. Yeah, you find that maybe the type J is slightly bigger, and once you put it in the autoclave and try to close, you're going to have leakages. Like the gasket is not going to actually attach to the thermocouple. So you may go for a type K with maybe 1 millimeter thin, such that once you close, it may not have the leakage. Okay, so even when we are looking at this, like I was saying, this is an introductory, it is an eye opener. What do we need? So when we go into the specifications, that's where they actually come from. So we have the thermocouples. You could have data loggers. Okay, data loggers, these are simple equipment that you're going to just, you know, get one logger, put it into the autoclave, and then it starts taking a reading. We shall see as we move forward. Then we have another parameter, which is the pressure. Pressure, we also have the best one is the data logger. We are doing the key parameters that we must be calibrating. I mentioned the temperature and the word pressure. So for pressure, we like I mentioned, it's the data loggers that give us accurate results because the equipment is running, so you don't want to stop. However, sometimes you may want to calibrate the gauge to be sure that the gauge is giving you the right reading, the right indication of what is inside. So you're able to calibrate the pressure gauge. So when you're calibrating the pressure gauge, you also need a gauge. You need the standard gauge to calibrate the gauges. Then the third parameter is the time. Remember we said if you're looking at sterilization time, you want to sterilize at 30, maybe at 30 minutes, at 25 minutes, at 15 minutes for drying, whichever. So we need to make sure that the timer is actually performing right. So we need to perform the calibration of the time. Okay, Janet, kindly move for me. I think I lost the rights because I changed. All right, thank you. So as we are doing calibrations, before you actually start the calibration of any equipment, we always have what we call the pre-calibration procedures. So these are like the checks so that you don't start an equipment to start calibrating, then you reach in between and then you realize the equipment is actually not functioning. So remember, for calibration, the equipment has to be, so you want to verify whether it is giving you accurate results. Okay, so we need to do the pre-calibration check. First, we do the visual inspection. You want to see that there are no, the door is well, the gasket is okay, there are no leaks, the jacket is fine, and so on. The electrical and the water connections where applicable, you want to be sure that there's distilled water. You don't so that you don't so that you don't end or abort a procedure just because there is no water. Okay. And then it is also good to do a bore and dick test because this helps us to know that the jacket is really able to maintain the pressures, the right pressures in the chamber. So by the time the bore and dick test is complete and we know that it has ended it very well, then we know that this the problem now I changed the gadget. I'm using the phone. All right. So the bore and dick, if it is complete, then we know that the equipment is able to actually perform or it's able to, to do a complete test. All right. So these are the pre-calibration procedures. Now the next And then you know that let me have a logger at the top, I have a logger in the middle, and I have a logger at the bottom for the top loading. And then for the horizontal loading, you may decide to have a logger maybe at the right, a logger in the middle, and the logger at the back. Then afterwards, you start the autoclave. Okay, but if it is a small one, you can just have one logger and place it in the middle. Then you close the door and start the autoclave. After the cycle is complete, you remove the data logger and extract the data. When you extract this data, they normally come as CSV files, which are like Excel files. You're able to read using the Excel, analyze this data, and generate a report or certificate. So why we say to analyze the data is that, remember, the logger has started recording maybe immediately or before the sterilization occurred. Remember, our target was to get the sterilization point maybe 121 degrees. So you want to eliminate the ones that were not at 121 before the sterilization started. Okay, so once the sterilization started, that's your time that you're looking. Remember, it is going to record for you the time. So here, you as the person who is calibrating, you're going to record when the sterilization time started. Maybe it started at 3:15. So when you're downloading this data, you know that from 3:15 onwards, that was the 121. That's when the autoclave was supposed to have attained the 121. Okay, so you analyze this data and generate a report. So that is for the data logger. If you're using the thermocouple, I had the picture for the autoclave, but it was not coming out clearly. So ignore, this is a fridge, but they have the same setup. But all I wanted is for us to see this. This is a thermocouple reader. So you place your thermocouples inside the chamber. There are some also which are hanging here. These are the thermocouples that we are talking about. So this tip, this head, the yellow one that you're seeing, is the one that we are going to place into the reader, and then we read. It is also the same. You may find that you have a very small chamber. If you have a very small chamber, you can put one piece. You can put 3 pieces, maybe on the left, the middle, and the right. Or still, if it is vertical, the top, the middle, and the bottom. And then you take your readings. So like here, the person is actually taking the readings from the chamber. So you want to see at the top here, what was the reading, or what is the reading. So once the sterilization period starts, then you come and actually start this reading. Okay, so the same thing after you have recorded. So here you'll need a data sheet where you're coding your first data, your raw data that we call raw data. So you have to have a data sheet. Okay, and you're going to verify your standard. So our thermocouple reader and the thermocouples will be the standard, and then we have the unit under test, which we also term as the UUT. The unit under test will now be your chamber. So what is the chamber displaying versus what your standard is displaying? Okay. So after the cycle is complete, you remove your thermocouples, analyze this data still, and generate a certificate. All right. For the time, we are going to have a digital timer, and then you start. You're supposed to start this timer and stop the timer at the same time. So you have, for time calibration is a bit tricky. So you have to be alert. In case you miss 1 second, you're going to have a delay in the stopping. Okay, so you have to be sure that sterilization is next. Remember, these autoclaves, sometimes they give even the countdown. So you have to be on standby. You may decide that maybe sterilization time is not easy for me to use to calibrate. Then you look for another stage, because at the end of the day, you're calibrating the timer. So it is irrespective of which stage that you want to actually calibrate, because this timer is the same timer that you're using to set the drying time. It is the same that you're using to set the sterilization time. So we just want to verify the performance of the timer. Okay, so you will start and stop, and then you read the standard and the unit under test or the UUT, right? Then for the pressure gauges, like I said, sometimes you may want to calibrate the pressure gauge to be sure that the indication of the pressure gauge is a reflection of what is inside the chamber. So you have to disconnect the gauge from the autoclave, and then we use a standard pressure gauge, which is this in the middle. So we have our pressure gauges that we want to calibrate. So you pump the pressure, whatever is reading here, you compare it with what is reading on this side. So because of hysteresis, we normally calibrate going upwards, maybe from 0 to 10 bars, and then also again from 10 to 0 bars. So we do up and down to cover for hysteresis. Okay? And then you analyze and generate a report. Okay, so basically, after we have done all this, you need to, like I said, we need to have conformity. You have to be sure that whatever data that you're producing conforms to the 17025. So what are the key things that the 17025 highlights? It has so many things, but the key thing when you're doing calibration, one is traceability. And when we talk of the word traceability, metrological traceability, you're looking at your measurements being linked to the SI unit of measurement. For example, if you're doing mass, you're supposed to be linking to the SI unit of mass, which is a kilogram. If you're doing temperature, we are going to link ourselves to the Kelvin. Okay, so we want to be sure that our equipment that we are using are also calibrated, and they must be calibrated by a national body. Okay, because these national bodies will also go and refer or make their references to the international bodies. Okay, the people that are performing the calibrations must be trained. Okay, they have to be competent. All right, that is all traceability. The method that you're using, that you're calibrating these autoclaves, it has to be acceptable. Okay, if it is an internal method that you developed by yourself, then you have to validate it and tell us that this method, it is my own method, but I'm actually getting the same results with whoever is using another method. Okay, then the reporting should be a standard reporting. You have to have a report which shows all the aspects that are listed within the 17025. You have to show the title, you have to show who is calibrating. This is just on the right side is just a sample of our certificate, the details of the equipment, the traceability details, and the results. And within the results, we have to give the uncertainty of measurement. Okay, so these uncertainties of measurement define the uncertainty of measurements define what we call the calibration. If you don't have uncertainty of measurements, then all what we are doing is a verification. Any questions? That is what I wanted to share. So if we have any questions related to what I have shared, kindly let's have a few, and then we shall also have a point of discussion where we can talk of the common faults with these autoclaves. Thank you.
Thank you very much, engineers. So at this point, to our audience, I'll just have I will just take some few questions. If there's anyone who has a question, may you please raise your hand, and we'll ask you to unmute yourself and speak. Or you can just type your question in the chat, and then the engineer will take your question. Over to you, the audience. If you have any questions or maybe comments based on the presentation, please bring them forward. Yes, James, you have a hand. You can unmute yourself and speak.
Yes, I have a simple question. So after how many months or weeks are we supposed to do this calibration? Maybe you may have spoken about it earlier. So if you have done that, maybe you can repeat for me. So how often are we supposed to do this calibration?
Thank you very much. Over to you, engineers. You can take the question.
Yeah, so for calibration, we are actually, like I was mentioning, that 17025 standard does not actually allow us to give recommendations for the next due date for the client. So most of the time we we leave it to the users to actually determine the next calibration date of an equipment, irrespective, even if it's autoclaves also. But most of the time, the manufacturers tell you at least once a year, at least once a year. So it is upon you to see whether your clients actually perform calibrations at least once a year, or once they perform a verification and realize that the equipment can actually stay for 3 years before recalibration, it is still also fine, because this recalibration, it has so many factors. One, we look at the frequency. How often are these people using this equipment? They are looking at how many people are actually using the equipment. You see, if it is one hand that is operating an instrument, you may find that it may take long for it to depreciate. But you may find that if there are so many hands, people handle equipment differently. So you will find that it may require measurements or testing again. So this is practically most of the time left for the users. But at least once a year, you could actually do that. Yeah.
All right. Yes, James Bezos, you can speak.
Thank you. Thank you. Also, I have a second question. You have spoken about how you could determine or verify that the pressure gauge or the temperature sensor or the timer is working accordingly. Now, after I have measured using the standard equipment or the data loggers and the digital timer, and I've found out, let's say the timer does not work properly or does not align, the times does not align. My timing with the digital timer and the timer from the machine do not align. That means maybe my device's timer has to be recalibrated. So where is the interface in the machine, in the autoclaves, that allows me as an engineer to recalibrate it, to change the values of the timer? It applies to both. The question applies to both the pressure gauges, the temperature sensors, and the timer. Where are the interfaces in our machines that allows us to change the values so that we can realign them with it? We can recalibrate them to be accurate.
Okay. Thank you, James. So most of the time we all procure equipment differently. We have I'll use the name advanced manufacturers, and then we have those other manufacturers that are following the others. So most of the time, equipment that have been manufactured by advanced manufacturers always give us a section where we can do internal adjustments for a particular equipment. If, like you said, it is irrespective whether it's even an autoclave. You could even go on a fridge and you're able to access where you can add in a correction factor that you have gotten. For example, you may, once you set 121 and you realize it is actually reading 120. So you can go and add in a correction factor of 1 so that it can pick it. Those are there. If you're able to do that in the interface of the settings, it can be done. However, for those practically possible, then you may have to do it manually, and you tell them that customize the settings. So instead of you going to 121, please customize this setting and put 122, so that at 122 it is actually reading 121. The same thing with the timer. Tell them if it is not practically possible to do the internal adjustment, the external, get an external timer and you time your measurements. Okay, and this cuts across all equipment, irrespective, even if they are thermometers, even if they are, so thermometers, you put for them a correction factor. They know that once they are reading, the sensor actually is reading 22, but there is a correction of maybe a 1. So it means there is, in actual sense, if it is 22, it is actually 23. I hope I've answered that. I'm also seeing another question. So for the calibration certificate, is it like the medical license, that is valid internationally, or it's usable just in Uganda after attaining in Uganda. No, it is a document that you release a result. Once you have performed the calibration, the client needs a result, a calibration result. So this is the certificate that you're going to give, or a report. You may want to call it a report, you may want to call it a certificate. However, it follows the 17025 aspects. Okay, all right. Thank you.
Thank you very much, Engineer Rod. Before I go back to James, I know you have also raised another hand. There's a question about how to get updates on Doctrine Alliance activities and such trainings. Please just type in your email. When we get your email, we will always make sure that we give you the update of our activities. Yes, James, you can come in.
Okay. According to my humble experience here in Tanzania, institutions, healthcare institutions, these data loggers, the temperature loggers and the pressure loggers and these digital timers that are specifically purchased or bought for recalibration of these autoclaves are very rare, meaning that we face the challenge as engineers. We face the challenge to be able to convince the procurement department, who may not understand clearly what is the need for these recalibrating tools. Now, for example, the question is in the case of autoclaves, if you ask for these recalibration tools like these data loggers and timers, digital timers, they will tell you that we have the strips, the sterilization strips, which will indicate if the sterilization was successful. So if we have the strips and they show that the sterilization was successful or was not successful, we do not need these recalibration tools to check the quality of the equipment of the autoclave. So you get lost in the points that on how you can convince them to buy these calibration tools while you have the sterilization strips. So in your country maybe, or in your area of work, what are the reasons that you really used and they convinced them to support you financially to purchase these calibration tools on top of the sterilization strips?
Thank you, James. I'll say this could be another point of discussion. Calibration, most of the time it is the willingness of the top management. So most of the time, the proposal that you write to the management will determine. The strips are being used to verify that sterilization has actually taken place. Okay, but it may not bring out the actual performance of the equipment. I know in most of the instances that you have experienced as engineers that if the person is setting, is supposed to be setting 121, they will tell you, no, nowadays that machine does not sterilize at 121. You put the one of 134. That's when it will sterilize. Okay, so it means that for them to sterilize, they are spending longer hours to get the result of changing that. But then you want to ensure that all your equipment are calibrated. You have what can I call it? You have so many. Okay, let me say you have so many aspects that you consider that the equipment is functioning well. If they are going to recalibrate, not to recalibrate, if they are going to sterilize these things twice for them to actually be able to sterilize, it means that the equipment is not actually functioning as it's supposed to be. Yeah. So for them, they are aiming at that. It means that there is a lot of consumption of power. There is a lot of time wastage. There is so much. And also these indicators, sometimes they could even expire. You don't know that they have expired. And because it's all in the name of, as long as it changes color, okay? Sometimes they may be out of stock and yet they need to actually perform the sterilization. But as long as you have already calibrated the equipment, you know that at least you have that confidence that the items are actually calibrated and we are safe that calibration is going to take place. Yes, and also to add, they are expensive. The data loggers are expensive. They are rare to find. And yeah, but if there is a will by the management, then they will buy them. But it also determines or depends on how you have written the proposal. Okay, so that is another point of discussion that we can do. We may not end that now. Yeah.
All right, thank you very much, Engineer Rose. I hope, James, your questions have been addressed. Now we have kept the audience waiting for a very long time. We appreciate and we are really thankful for your patience. You stayed, despite the fact that we had some hinges in terms of network, you stayed, and we really appreciate. For those who are asking for a PowerPoint presentation, we are going to share the recorded session. And yeah, or reaching this point, I would also like to say thank you to Engineer Rose for sparing your precious time to be with us. I know you're a very busy person, but you tried your best, and we really appreciate your time. And we hope that the information that you have shared today is going to help a lot of engineers out there. We have pasted a form in the chat for you to give us the feedback, the audience, how our session has been and what you would want us to improve or work on in the next session. So please fill the form. We also pasted a link to the app, the BME Econs app, the app that has been developed by the Oxygen Alliance to enable biomedical engineers and technicians. Have a look at different manuals, videos on how to maintain different medical equipment, and also get answers from other engineers across the world. So please, you can also have a look at that. Reaching this far, if there are no any other questions, I would just like to hear from Engineer Rose if you have any closing remarks, and then we'll have to close the call. Thank you.
Thank you very much, Janet. I would just like to take this opportunity to thank Oxygen Alliance for giving us this platform where we can actually have a discussion as biomedical engineers. I would also take this opportunity to thank the participants for their patience and also the time that they've taken off their busy schedules to actually attend this webinar. And I hope that we have learned so much from them. And learning does not stop. This is the beginning, and it may not be the end. So I wish, and it is my humble request, that we stay in touch. I mentioned all the aspects that we do, that we guide. So in case of anything, you can still reach out to me so that we can have further engagements. Thank you so much.
Thank you very much, Engineer Rose. Thanks, everyone, and we're wishing
You're welcome.
I know, Arthur, you're raising your hand. I don't know if it's a hand or Arthur.
Yes, please. Thank you very much for the opportunity. I was kindly requesting that Engineer Rose share with us also her contact so that we can continue being in touch.
All right, thank you very much. I hope, Engineer Rose, you have heard that. If it's okay for you to do so, you can just paste your email in the chat so that people can also get hold of it. Reaching this far, I'd like to say thank you to everyone and goodbye.